Welcome to Nano Matters, the podcast that explores examples of nanotechnology. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Here with me today is Himanshu Jain, the T.L. Diamond Distinguished Chair in Engineering and Applied Science at Lehigh University. Himanshu, when people think of glass, they typically think of windows. Can you share a little bit of information about glass from your perspective and why you study it?
Yeah, glass is one of the most versatile materials. You can shape it in any form you like. It is chemically very durable, and that we know from the windows, they don't go away. And it is optically clear, transparent. It can be made into colored glasses. It can be turned into optical fiber that is used to make the internet possible. So it is one of the most versatile materials that we have. And that is why its applications are literally enormous.
So you mentioned fiber optics. Can you give some other examples of applications or technology-related applications of glasses?
I want to tell you about the dinner that I had with a colleague in Cairo, Egypt, at some conference. And the lady sitting next to me asked me, "So what do you do?" I said, "I work on glass." She says, "You guys are no good." I said, "Oh, what made you say that?" She said, "Look, I use in my patients the glass, but it's no good." And she happened to be a prosthodontist and a tissue regeneration dentist. She was interested in tissue engineering. She says, "I want to have this filling with bioglass, which is a commercial product. And then I want it to disappear because I don't want it to be sitting in the patient's mouth for months and years." So I said, "Look, this is very interesting because for hundreds and thousands of years, glass scientists have worked to make glass durable. And you want the glass to dissolve quickly in time." So I took this as a challenge, and then we started thinking about it. And the idea came, very simple idea. We know that the rate of dissolution of a material depends on its surface area. So if we can make the material large surface area, then it can be useful in basically solving her problem. So we developed at Lehigh the whole technology to make a material that has to be nanoporous. And for tissue engineering, we would like to have a material which has porosity which is several times larger than the size of the cells. And so the cells are about 25 micron. And so we would like to have the material which has porosity on the scale of 100 to 200 micron. And then to give large surface area, we want the material to have 1,000 or 10,000 times smaller pores at the same time. So we came up with the material which we call tailored amorphous multiporous structure, or TAMP. And TAMP is a nano macro porous at the same time. And so we developed this material, and our friend from that dinner, we have now collaborated for over 10 years now. And I was quite happy to see that a year or so, a couple of years ago, she finally conducted a clinical trial based on that dinner that we had. And so along the way, I worked with other colleagues in multiple countries and different disciplines. So I'm working now with a colleague, cell biologist, Matthias Falk at Lehigh. I'm working with George Huang at University of Tennessee. He's a dentist. And what we have learned that this particular material, which is nanomacroporous, but the size of nanopores has very intriguing effect. It's not just the purpose with which we started. We discovered something in addition to making it dissolve faster, but we found that cells prefer certain nanometer sized pores in order to grow faster, to attach the cells, and to make the tissue faster. So we ended up discovering this new thing, which is the subject of a recent publication that came out. And so you can see that there's so much you can do with the glass, especially when I was growing up. If glass got into your foot, you wanted to get it out. And here we are trying to put the glass in the human body to make it work for us. So you can see that the possibilities of glass.
The example that you just shared relates to the physical structure of glass and the benefits of having this porous structure that you could create. And when we look through a window, it's the optical properties that we really consider, the transparency and being able to have it transparent but airtight and protect us from the elements. Can you share some other properties in glasses that you can exploit, whether they're electrical properties or other types of properties that people might not consider when they think of glass?
Yeah, so generally people think of glass as an insulator, right? It's electrical insulator, it is thermal insulator. And that is why we have glass to protect us from cold or heat outside. And so there are interests in making the glass conducting. For example, if you want to use glass in a battery, and so the glass will be good electrical conductor where we would like to have. At the same time, there are applications where we would like to have glass conducting and also transparent. So these are some of the challenges that one would like to develop with glasses, that we can have all these apparently opposing properties in the same material. And this is where nanotechnology can help, that on the nanoscale, we can create the glass conducting where much of the rest of the glass is still insulating. And there are definitely applications where such a material would be fantastic, for example, in displays and so on.
What is it about the glass that you change at the nanoscale? Is it using dopants or different elements in the glasses in order to tailor the properties that you're looking for?
I think this is exactly what needs to be done. Electrical conductivity is a complex property. You can have electrical conductivity due to transport of electrons, and there are different ways for the electrons to transport, or it can be due to transport of ionic species, atomic species, charged species. And so depending on the application, we can modify these various mechanisms to be effective in a given piece of glass in a certain area of that sample. And that's where I think you can modify, for example, the dopant or the oxidation state of the dopant, and that can allow you to create high conductivity paths.
You've talked about a lot of different ways that glass can be used. So if a high school student was interested in studying an area to pursue research in glass, what types of subjects should they focus on?
Yeah, so if the student is interested in developing new glasses, then I would say a strong background in physical sciences, could be physics, chemistry, or material science. That'll come very handy. You understand your fundamentals have to be very strong and well understood. On the other hand, if the student is interested in the application of the glass, then I would say a program in material science and engineering will be a good starting place. And then the student can move into electrical industry or mechanical behavior of the materials in different areas, depending on where the student would like to head for the career.
Himanshu, I want to thank you again for taking the time to talk with us today. Do you have any closing thoughts that you might have with our listeners?
Yeah, I would say think of glass as a very versatile material because the glass is made from molten material. It is fluid. And so think of glass as a fluid that you can play with. And you can modify the structure and the properties of the glass on the scale that you choose to do that. You can be an artist and transform the glass into beautiful object on a very large scale, or you can be an artist on the nano scale and turn the glass into nanotechnology miracle. Think of glass as a material that is so amenable to changes by the operator.